Hello everyone and welcome to Keeru's online lectures. I am Keeraj Jhamtani and today's topic is Haloalkanes, Haloarenes part 6. In part 1 we studied introduction, reactions in organic chemistry, nucleophilic substitution and elimination reaction. In part 2 substitution, elimination reaction and stereochemistry we studied. In part 3 preparation and reactions of alkyl halides. In part 4 preparation and reaction of haloarenes. In part 5 we studied reaction of special alkyl halides and about trihalides and tetrahalides. Now in part 6 we are going to study about important compounds of haloalkanes, haloarenes and their preparation and reactions. So starting with the important compound of haloalkanes, that is chloroform. Now the formula for chloroform is CHCl3. How can we prepare this chloroform? So it can be prepared by using ethyl alcohol. So we will take ethyl alcohol like C2H5OH. Now this ethyl alcohol reacts with, over here means the chloroform can be prepared using NaOH or Cl2 or CaOCl2. So first reaction which takes place over here is NaOH plus Cl2, it will give NaOCl plus HCl. This on decomposition forms NaCl plus nascent oxygen. Now this C2H5OH will oxidize and thus it is alcohol, so it will form aldehyde CH3CHO. On reaction with chlorine, so the 3 hydrogen atom will be substituted by chlorine, will get CCl3CHO. This is known as chloral. So chloral, when it reacts with CaOH whole twice, it forms CHCl3 plus, that means this bond breaks up over here and this H comes here, thus it forms CHCl3 plus HCOO whole twice Ca, that is calcium formate. Now similar reaction like we have chloral. Now when this chloral on hydrolysis, let us suppose we have chloral CaCl3CHO on hydrolysis, that is on addition of water, it forms CCl3 CH OH OH. Now what will happen? Again this bond will break. So this bond will break and here it will react with NaOH. So it will form CHCl3 plus HCOONA and this water will be eliminated, water. So this is how the formation of the preparation of chloroform takes place by ethyl alcohol. Over here this reaction, that is chloroform, is prepared by 2 ols, 2 ones and ethyl alcohol. Now coming on to methyl ketones, how this chloroform will be prepared by methyl ketones. So when methyl ketone, like we have CH3 CO CH3, it reacts with chlorine, so it will form CCl3 COCH3. So again now this bond will break up when it reacts with calcium hydroxide. So when this bond breaks up, it will form CHCl3 plus CH3COO whole twice Ca. So the first reaction which we studied was preparing by ethyl alcohol. Second is by methyl ketones. Third, we can prepare chloroform using carbon tetrachloride. So this carbon tetrachloride on hydrogenation, it forms chloroform plus HCl in presence of Fe plus H2O and in acidic medium, that is HCl. This is how chloroform can be prepared. The next is chlorination of methane. So methane on chlorination at 370 degrees Celsius in diffused sunlight, it forms CHCl3 plus HCl. So this was all about the preparation of chloroform. Coming on to the reactions of chloroform. First reaction is oxidation. So chloroform, in presence of light and air, it forms highly poisonous gas, that is phosgene. So CHCl3, on oxidation it forms highly poisonous gas, which is phosgene plus HCl. Next is carbylamine reaction. So the carbylamine reaction is basically given by isocyanides only. So the isocyanides, they have a very disagreeable smell. So this reaction is basically used as a test of chloroform, and it is also used as a test of primary aliphatic and aromatic amines. So this carbylamine reaction is given by aliphatic, primary aliphatic and aromatic amines. So this RNH2, it reacts with chloroform in basic medium, that is KOH. It forms isocyanide. These isocyanides have a very disagreeable smell. So this indicates isocyanides are formed, and isocyanides will only be formed when there is chloroform. So thus this is a test of chloroform. Coming on to next, which is hydrolysis. So CHCl3, on hydrolysis they will form, here all chlorine group will be replaced by OH. So CHOH, OH, OH. Now 3 OH group in 1 carbon is unstable, so water will be removed from here. So when we will remove water, we will get HCOOH. Again, when it reacts with KOH, so it forms HCOOK plus H2O. So this is how hydrolysis of chloroform takes place. Coming on to next, formation of acetylene. So chloroform CHCl3, when it reacts with Ag, so they form acetylene. Now what happens over here, 2 moles of chloroform we take, and here 6 Ag. So 6 AgCl is removed, and thus CH triple bond CH we get, which is acetylene. Formation of chloropicrine. Chloropicrine is an insecticide. So when chloroform, it reacts with HNO3, so here again the H will be replaced by NO2 group. So it will get CCl3NO2. This is known as chloropicrine, and this chloropicrine is an insecticide. Next is formation of chloritone. So chloritone, that is acetone. So when chloroform CHCl3 reacts with acetone CH3COCH3, it will form chloritone. So here what happens, we have CHCl3, so this H will be replaced by this CH3COCH3 group. So here we will get CH3 whole twice. Now H will shift there with O, here we will get OH, and this is CCl3. So basically in this reaction, what happened is, this CCl3 was here, C along with CH was there, so O shifted to this side, so COH, and with this this CO was there, so CH3 whole twice is attached over here. This is known as chloritone. Coming on to next, the next important compound is Iodofrom. Iodofrom is basically CHI3. Now how can we prepare this Iodofrom? Again, as we prepared chloroform, we took Cl2. When we will prepare Iodofrom like C2H5OH, we will take I2 plus sodium carbonate. So we will get over here CHI3, which is a yellow solid, plus HCOONA plus NaI plus CO2. Now this reaction is also given by ketone, that is 2 ones. So CH3COCH3 plus I2 plus Na2CO3. again it will form CHI3. Now here in place of HCOONA we will get CH3COONA, because here it is CH3 group, and NaI plus H2O plus CO2 will be formed. So this is how Iodofrom will be prepared. The next compound is carbon tetrachloride. So carbon tetrachloride, it can be prepared. The first preparation is methane on chlorination. So methane on chlorination, in diffuse sunlight we get CCl4 plus 4HCl. Similarly, second preparation method is carbon disulfide on chlorination in presence of aluminium chloride will give carbon tetrachloride plus S2Cl2. Now this S2Cl2 is separated by fractional distillation, and then it is again treated with CS2 to give CCl4. Similarly, the third reaction we can prepare it by propane also. Moving on to the reactions of carbon tetrachloride. So carbon tetrachloride on reaction on oxidation, that is steam, this is steam on oxidation at 500 degrees Celsius, it forms COCl2 plus HCl. Next is carbon tetrachloride on reduction. So on reduction it will form chloroform with Fe and H2O plus HCl. Carbon tetrachloride on hydrolysis, KOH. So all Cl will be replaced by OH. Here we will get COH whole 4. Thus there will be removal of water. We will get CO2, which on reaction with KOH will form H2O plus K2CO3. Carbon tetrachloride on reaction with HF will form CCl2F2 plus HCl. This is known as ferron. Now moving on to next compound, which is vinyl chloride. Now vinyl chloride, vinyl group is a group in which the functional group is attached to the double bonded carbon. So CH2 double bond CH, this is a double bonded carbon. So chlorine is attached to this carbon only. This basically CH2 double bond CH2 is vinyl group. Now how we can prepare this vinyl group? So the first preparation is by alkyne, that is by ethyne. Ethyne on hydrohalogenation will form CH2 double bond CHCl. This is vinyl chloride. Similarly, vicinal dihalides, this is vicinal dihalides on reaction with alcoholic KOH, it will form CH2 double bond CHCl. Next is ethene, that is CH2 double bond CH2 on chlorination, it will form at 600 degrees Celsius, it will form CH2 double bond CHCl. And so this is how vinyl chloride is prepared by three methods: ethyne, vicinal dihalide and ethene. The reactions of vinyl chloride is, we have CH2 double bond CHCl. When it reacts with alcoholic KOH, this vinyl chloride, alcoholic KOH is basically performs hydrohalogenation, that is removal of hydrogen and halogen. So thus we get over here acetylene plus HCl. So halogen atom is vinyl chloride, it is quite stable and it does not respond to nucleophilic reactions easily. So it is due to resonance stabilization of vinyl chloride only. Thus it performs reaction with alcoholic KOH and it gives ethyne. Coming on to next, allyl chloride. So allyl chloride is basically the compound in which chlorine group is not attached to the double bonded carbon atom. Like this is double bonded carbon atom. So chlorine group is not attached to it. How we will prepare it? So we can prepare it by propene, CH2 double bond CH, CH3 when it on chlorination at 500 to 600 degrees Celsius, it will form CH2 double bond CH, CH2Cl. Similarly, allyl alcohol, that is CH2CH, CH2OH on reaction with PCl5, it will form CH2 double bond CH, CH2Cl plus POCl3 plus HCl. So, this is how we prepare allyl chloride. Now, allyl chloride, it shows two types of reactions. One is addition reaction and other is substitution reaction. So, addition, like we have CH2 double bond CH, CH2Cl. So, this on reaction with Cl2. So, Cl2 will be added to it. So, the double bonded carbon atom will be substituted. Here we will get CH2Cl and CHCl, CH2Cl. Similarly, if the reaction takes place with HBr, so negative part goes to the carbon having less number of hydrogen. So, here we will get CH3, CH, Br, CH2Cl. Now, the addition of over here, it follows Markovnich's rule. In presence of peroxide, the products formed will be different because peroxide says negative part goes to the carbon having more number of hydrogen. Next is nucleophilic substitution reaction. So, like we have CH2 double bond CH, CH2Cl, nucleophilic substitution. So, here the substitution will take place aqueous KOH. So, Cl will be replaced by OH group, we will get CH2 double bond CH, CH2OH. Similarly, substitution is taking place with ammonia. So, Cl will again be replaced by NH2. So, this Cl and H will be replaced. Here Cl and K. So, here we will get KCl and here we will get HCl. So, CH2 double bond CH, CH2, NH2. Similarly, when it reacts with KCN, we will get cyanide. So, KCl will be removed, CH2 double bond CH, CH2CN plus KCl. When it reacts with magnesium in dry ether, so we get Grignard reagent, which is CH2 double bond CH, CH2 MgCl, which is a Grignard reagent. Now, moving on to the last compound of haloarenes, that is benzyl chloride. So, benzyl chloride can be written as C6H5 CH2Cl, or we can write it as PHCH2Cl. So, how we will prepare it? So, first it is prepared by toluene. So, we have toluene. Toluene on chlorination, it forms benzyl chloride, which will form CH2Cl plus HCl. Similarly, we have benzaldehyde. Benzyl aldehyde. So, benzyl aldehyde it reacts with ZnCl2. So, it forms benzyl chloride, CH2Cl. Next, we have benzyl alcohol, CH2OH. On reaction with PCl5, it forms benzyl chloride. So, this is about the preparation of benzyl chloride. Moving on to the reactions of benzyl chloride. So, the first reaction which benzyl chloride takes is nucleophilic substitution reaction. We have benzyl chloride, which is CH2Cl. Now, nucleophilic substitution, the first reaction will take place with aqueous KOH. So, in aqueous KOH, Cl will be replaced by OH. Here we will get CH2OH. Next, with KCN, again K and Cl will be removed. Here also KCl will get, here also KCl, and here benzene with CH2CN. Similarly, the last nucleophilic substitution reaction is with ammonia. So, with ammonia we will get CH2NH2 plus HCl. Next is Wood's reaction. So, when 2 moles of benzyl chloride, that is CH2Cl, it reacts with sodium, it forms, so here we have CH2, because this Na and Cl will be removed, this CH2, CH2 and then benzene group will be attached. Similarly, benzyl chloride on oxidation, we have CH2Cl on oxidation with K2Cr2O7, it forms benzoic acid. So, in today's video we studied about the compounds of haloalkanes and haloarenes. Hope you guys are finding videos helpful. So, do like, share and subscribe the channel. Thank you.